Welcome. Here we're going to talk about how to convert numbers into scientific notation. So sometimes we have really large numbers and really small numbers. It's really inconvenient to work with them, and so it's useful to convert them to scientific notation. Let's consider the following number, 3,600,000. And I don't want to write that down every time, or I have some other reason that I would like to work with a smaller number. Well, when we convert to scientific notation, we use the properties of exponents. We use the fact that 10 to the first power equals 10, 10 squared equals 100, 10 cubed equals 1,000, and so on. So if I multiply, say, the number 3.6 by 10, that gives me 36. Every time I multiply by 10, I move the decimal one spot to the right. So 3.6 times 10 squared, which is 100, moves my decimal over 2 places. So the exponent tells you how many places to move it. 3.6 times 10 cubed moves the decimal over 1, 2, 3. So we're adding those zeros, meaning I'm moving the decimal over. We could imagine a decimal place here, correct? So we're using that property. And if I want to move this into scientific notation, my decimal lies here at the end of the number. I'm going to go 1, 2, 3, 4, 5, 6. And we always stop when we reach the last. We always stop one spot to the left of the end, right? So we don't ever go all the way and do 0 point something, right? That would be weird. So instead, we always stop here at kind of the last value, and this would be 3.6 times 10 to the 6th, because I moved 6 spots. So in order to convert this back into a whole number, I move that decimal place over to the right 6 times. So this is how we will handle moving numbers into and out of scientific notation. If I give you 1.234 times 10 to the 9th, I'm going to move the decimal over 9 spots. So I like to do it this way. I'll count. The 1 doesn't count, but the 2, 3, 4. So that's my first, second, and third moving of the decimal. And then that was 3. I need to do 9. So I have 3, 4, 5, 6, 7, 8, 9. And then I'll add in my commas to make the number more manageable. But this is quite a large number. But moving it into scientific notation can make it a little easier to handle. Now, that's how you move very large numbers into scientific notation. Sometimes we have very small numbers. So, for example, 1.0004. This is quite small. And again, what I'm going to do is I'm going to move that decimal 1, 2, 3, 4. Here, I'm relying on the opposite property. So I have 10 to the negative 1 is 1 over 10. 10 to the negative 2 is 1 over 100. 10 to the negative 3 is 1 over 1,000. And if I have 4 times 10 to the negative 1, what I'm doing is I'm moving the decimal one place to the left. So this is 0.4. 4 times 10 to the negative 2, I move it 2 to the left. So 0.04. 4 times 10 to the negative 3 would be 0.004. So that's the property that we're relying on. If I'm looking back at my example, this decimal, in order to make this a whole number, needs to come 1, 2, 3, 4. So this is 4 times 10 to the negative 4th. Let's consider another example. 0.000356. Let me add one more 0 so it's different from what we did previously. So we'll do 0.0. There we go. So here again, I'm going to move the decimal to the right until I have gone to the right, until I reach just one of the non-zero numbers. So 1, 2, 3, 4, 5. I'm going to stop there. I only want one non-zero number, okay? So 1, 2, 3, 4, 5, and then I rewrite this as 3.56 times 10 to the negative fifth. So very small numbers have negative exponents, very large numbers have positive exponents, and that's one way to remember. Is it going to be big or small? Well, big numbers have positive exponents on the scientific notation. Really tiny numbers, decimal numbers, have negative exponents. Thank you so much for watching.